So chemistry, not my particular field, but I know we've got a lot of chemists in the community in the sci-viz side of things. For my biomedical sciences degree, we obviously need to cover like a certain small amount of chemistry, more specifically in terms of like specific types of bonding between elements for things like hydrogen bonds for like DNA structure, or, water is covalent and polar. So how does that help mix things in, solvent solutions, that kind of thing. And then like ionic things like salt. So if we're measuring or tracking like the change in salt content of the body, or what sodium's doing around the body, because it has lots of specific use cases, especially after it's lost the electron from its valence shell. So basically there will be a need-ish for me to be able to like produce some simple models of atomic structure. What I've done is I started to put together a like visual color reference for every element, and I also need to do different types of bonding, right? And I want to do it in a simple way where I can just attach things to grids. It's interesting because there are so many like conventions for how things like molecular compounds, proteins, etc. are displayed or should be displayed, even down to things like the radii. So, the general size of each element in relation to the other. And there's like these filling space methods that you've probably somewhat seen, even if you don't study or know anything about science. But if there's one thing I've learned, there's no such thing as a perfect visualization. Basically, visualizations are designed to present certain pieces of information within a certain context. That's like just the basic two principles of visualizing. So for example, one thing I read about recently was just on a very simple level when it comes to chemical compounds and visualizing them. By the way, this is wrong because you can tell that one is a different color here in the H2O molecule. If you wrote down the chemical compound like H2O, it tells you what's inside of it, but it doesn't tell you how they're structured. But a more structural formula would, but you can actually see that the oxygen is a center point from which hydrogen comes off. So that's why things like this are important. But while I was looking into all of this, I thought, you know what? If I build my own like atomic viz system for Blender, do I need to follow conventions? No, not realistically. Conventions aren't law. And this also reminds me of a conversation I had. I think it was like a comment thread on a CG Matter video where CG Matter was, I think, experimenting with doing, It was aerodynamics in geometry nodes. And it was quite a cool result. And I think I left a comment somewhere saying, hey, yeah, this is really cool. I always wondered whether you could do something like this. And then I got like an actually comment response, which was like, yeah, this isn't actually real aerodynamics because it's not simulating vortices and things like that. And I was like, all right, you're wrong. There is no such thing as a perfect physics simulation because we don't have a complete picture of physics. So there can't be a perfect physics sim. When using tools like aerodynamic sims to improve design, realistically, if the sim is good enough, regardless of what features it contains, to tell that A is better or worse than B in a blunt aerodynamic environment, then that tool has succeeded. So even if it doesn't simulate every behavior of airflow, it is still a useful aerodynamics tool, even if it's a dumb approximation of how air moves. You'd be able to tell that a manatee is less aerodynamic than a sparrow. So that's just one thing to keep in mind when it comes to like sci-fi stuff. It's been interesting because like I look at a lot of educational content around this stuff now, and some of the diagrams are really bad. Like you can have things which perfectly follow conventions, but they just look awful. And they'd be way worse at conveying the information than something that was not strictly accurate, but did look better, or is easier for someone to understand on a glance. So basically, I put together this little file quickly. It's got every element in the periodic table, maybe minus a few. I haven't really done a proof check of that yet. I'm following the JMOL CPK color conventions. I have a link here on the screen to a PDF. It's a very good PDF, by the way. Here it is. So this is where I was taking the hexadecimal codes from. Like I said, I decided to skip out on doing the different radii for each of the molecules. And now kind of the next step is just thinking about which preferential way I'd like to visualize the atoms interacting and maybe how I can represent different bonds. So that's kind of the next step going forward there. So another reason I want to mention this is because this file is now on my Patreon for the Silver tier members and above. It's not actually on there yet, but it will be by the time this video goes out. So Silver tier members and above get access to this members lounge thing, and under the Blender art files and experiments I will put it in here as well. You may also notice that I have these kind of introductory videos for each section, so if you are signed sign up to the Patreon and you need a bit of like guidance, or you want a bit of a friendly intro to the stuff I have available, then I've got these videos all over the place to kind of help like guide you into it as well. Hopefully that makes it more personable. And even though this is an incomplete system, it's just an experimental file, I thought it would be nice for, you know, potential Scythers like patrons to have a little play around. So what I also did was each of these spheres are individual, so they represent each element. If I open it up, we can see this is bismuth. We've got here gallium, copper, rhodium, etc. And in this file, I've marked them as assets. I did have categories, but I've lost them, it seems, for some reason. But basically, you can go to the filter in the asset browser and filter them by materials. And the materials, they have, you know, these perfectly nice visual icons to them. You'll notice that the materials have this line thing going on. That is a specific visual style that I have chosen, right? Because if we're looking at things like this, I didn't really like the idea of just a flat color. I like there being these lines. It helps to define the shape better, makes it a bit easier to see, I think, on a first glance. In the file, I've also tested having like text point and stay pointing at the camera. Again, this is wrong because that's carbon. So basically, in theory, what I could do is I can just click and drag a different material from a different element onto it. But that should be hydrogen. So where is hydrogen? There it is. Nice. So now that's fixed. The lines on the material come from the brushed metal node group, which is from my modular metals pack, I think. Or it might be procedural patterns, but like I said, this is included in the Patreon blend file anyway. Since objects are also included in the asset library, despite the fact that they don't have a colored icon, you can drag them in as well. So we could bring in like cadmium and start using that. So like I said, just like a kind of basic starting point for me doing atomic, molecular, compound viz, etc. And I'll add to that over time. But I figure that putting like unfinished projects on the Patreon is a good thing because it will let people still learn, maybe carry on, maybe adapt it for their own purposes. All right, so thanks for watching. Put something atomic related in the comments if you made it this far. Have a great day, and I'll see you next time.